Basic Calculus Part 3, Tangents to Curves. There we are. There's the derivative from first principles, and it's all about the gradient of a tangent, where we had b and a, and we brought b closer and closer, making this h tend to 0, and at the point at which h became 0, this became a tangent at that point. That's all in previous derivatives on basic calculus. So in future, derivative of a function is the instant gradient of a function. When you see gradient of a function or gradient at a point or gradient of a tangent to the function, think derivative. Right, determine the gradient of the tangent to the curve at the given value. Think derivative. Gradient of the tangent to the curve. Determine the derivative at x equals 5. Well, let's find the derivative. Substitute x equals 5. You get 10. So there is the gradient at x equals 5 is 10. Another one just with a slightly more complex derivative. Remember, that needs to be written as 4x to the minus 1 before we can differentiate it. Now we differentiate minus 4x to the minus 2, which of course is minus 4 over x squared. Substitute x equals negative 2 into that, and we get negative 1. Gradient equals negative 1. Looks about right. Gradient of the curve, 3x squared plus kx minus 5 is 8 at the point x equals 2. Find k. Well, gradient of the curve means derivative. So derivative equals 8 when x is 2. So gradient equals derivative, which is 6x plus k, and we know that derivative equals 8 when x equals 2. Substitute 2 for x, and we get k equal to negative 4. Gradient of the curve y equals x squared plus mx plus n, two variables, is negative 5 at the point minus 4 naught. Well, we are given two facts. We need two facts for two variables. I don't know if you remember that from your algebra. That's however many variables you need to find, you need that number of equations. First of all, we're told the gradient is minus 5. There's fact 1. And fact 2, we're told the point minus 4 naught lies on the curve, is on the curve. Well, let's start with this gradient of the curve, which means derivative equals 5 when x is minus 4. So, derivative, which is 2x plus m, and it's equal to minus 5 when x equals minus 4. Substitute the x value, and we get m equal to 3. We now know m is 3, so we can rewrite this equation with m equal to 3. Now to find the n, remember the other fact? Minus 4, 0 is on the curve. So therefore we can substitute minus 4, 0. And we get n equal to negative 4. Coincidence that it turns out as the same number. Nothing else, no magic. Find the equation of the tangent to the curve of y equals x squared plus x at the point 1, 2. Kind question. It didn't have to give you that 2. You could have got it by just taking 1 and substituting it in there and getting the y value. Now, in order to find the equation of a line, and this is the tangent, we need y minus y1 equals mx minus x1. That's the best way to find the equation of a straight line. If you do it by some other method, that's fine too, but this is the easiest way to do it, the quickest way, the most efficient way. Now, we're given x1, y1 is 1, 2. So now we still need to find m, which is the gradient, and immediately we hear gradient, we think derivative. So m equals the derivative at x equals 1. Differentiate 2x plus 1, substitute 1 for x, and it's 3. We've now finished. There's your 3, there's your x1, there's your y1. Y equals 3x minus 1. Looks about right. Find the equation of the tangent to that curve at the point where x equals negative 3. Right, so just one step more, you'd be being given the y value. So we need to find the y value. Let's do that first. Substitute in negative 3 into the original and we get y equal to 5. Now we're at the same place at which we started the previous example. We now know x1, y1. We need to find the gradient, which is the derivative. So we differentiate. We're going to get 2x plus 2. And we substitute negative 3 for x, and we get negative 4. So there we are. Negative 4 is our m value. Now, quite a useful thing is to see that it's changed sign. Y changed sign y1, x changed sign x1. Because y changed sign y1, so y changed sign 5 minus 5. X changed sign x1, x changed sign negative 3 plus 3. And there's your m. Simplifying, there's your equation. Y equals minus 4x minus 7. Some exercises for you to do. Pause, try them first. In this first case, 3 steps. Find the y values by substituting original. Find the gradient by substituting this into the derivative. That'll give you your m value. And then use y minus y1 equals m, x minus x1. So into the originals to find the y value. We now have x1, y1, x1, y1, x1, y1. Tangent. Gradient equals. Now we substitute each of these into the gradient. Now we have m. So we can now use our equation. Remember once again, change sign y1. So in this case, we'll say y plus 1. There we'll say y plus 1. Change sign x1. So here we'll say x plus 1. Number 2, what is the value of a if the gradient of the tangent to the curve y equals ax cubed is 4 at x equals 1? Well, the gradient of the tangent to the curve, we think derivative. So what is a if derivative is 4 at x equals 1? So there's the derivative, y equals 3ax squared. I'll put it there because we need it in all 3. I don't want to have to keep redoing it. There we are. 3a times 1 squared, 3ax squared equals 4, 1, 4. A is 4 over 3. 3a 2 squared equals negative 2. Solving, we get a equal to negative 1/6. This looks terrible, but not really. I'm going to say 3a times x squared, so I'm going to get a squared, or x squared, and it's equal to a squared. So there we are. Now notice this is, I need to be careful. You can't just divide through by a squared because you need to take out a common factor. Not that it would matter, you'll see later, but in this case only. There we are, so take out, which means a is 0 or a is 1/3. But I'm going to suggest that there is trivial, what we call trivial, of no consequence, meaningless. Because we started with y equals ax cubed, which implies it's something x cubed. Now, if a is 0, that means we end up with y equals 0. And that's trivial because that's not really what we're dealing with. I don't know that you'd lose any marks, but I would lose marks in making this video if I didn't point that out. Next one, number 3. Find the point or points at which the gradient of the tangent curve is 1. Well, gradient of the tangent to the curve, derivative. Find the point or points at which the derivative of that equals 1. Right, so derivative equals 1. So let's differentiate, equals 1. Solving, the 11 goes across, divide by the 3, we get x squared equals 4. And we rush in and say x equals 2, but don't forget that if we have squared equals 4, then x equals plus or minus 2. Unless, of course, you're finding the length of a line or a time or something like that. Now we have the x values. We are asked to find points, so we must substitute in the original to get the y value. Quite a useful little way. I've just substituted and written it as plus or minus 2 rather than rewriting the equation twice. And there are answers. So from plus 2, I get minus 7. From minus 2, I get 21, which gives us 2 points. 2 minus 7 minus 2, 21. Number 4, find the point on the curve at which the tangent is parallel to that line. Well, in other words, the gradient of this line is 5. Gradient of this line is the tangent. Gradient to the tangent is the derivative. And remember, the tangent is parallel means equal gradients. Or the other way we can look at it is just simply derivative equals derivative. That's the best way to look at it, really, I guess. Right, so dy by dx equals 2x minus 3. And I'm going to put it equal to 5, because that's the derivative of the other one. Their derivatives are equal. Solving for x, we get x equal to 4. It says find the point, so we need to take 4 back into the original to get the y value. And there's our point. This one, perpendicular to the line. Now, perpendicular lines, their gradients multiply to give negative 1. They are negative inverses. So I'm going to write that as y equals first. There we are. Y equals half x minus 4. Minus 2y across to become plus 2y minus 8 this side. Switch it around, divide by 2. And we get that. So therefore we know derivative equals not that, but the flip with a negative. Notice that was quite natty. Let's do it once more. Notice this flips. There we are. And you get a negative 2. If this was negative, this would be plus. So derivative equals negative 2. Solving, you get x equal to half. We still need the y value. Substitute back into the original. Negative 5 over 4. And there is our point. Find t if the gradient of the tangent curve, in other words, find t if the derivative of that is negative 2 when x is 1. So therefore I'm going to find the gradient. First of all, I'm going to write it as separate fractions, which means I have tx to the minus 1 minus 1. Differentiating that now, I get minus tx to the minus 2, which is minus t over x squared. And I'm going to put it at x equal to minus 2 at x equals 1. So therefore, minus 2 over 1 squared equals minus t over 1 squared equals minus 2. Solving, t equals 2. Another example, determine the equation of the tangent to the curve which is parallel to that line. Well, parallel lines means equal gradients, which means equal derivatives. So I need to know the x value. So I'm going to put derivatives equal to one another. There we are. So there's the derivative of that one. I'm going to put it equal to 1. Solving, you get x equal to a quarter. So therefore I now know this is a quarter. I need to sub into the original because it's this curved line, the parabola, which I need to find the y value. And y is 11 over 8. So now I know my gradient is 1. I know x1, y1 is a quarter, 11 over 8. So therefore I can substitute into my equation formula. Solving that, we get x equal y equals x plus 9 over 8. A whole mountain of work here for you to do. Pause, try it yourself first. It's good for you. Then look at the answers. Pretty straightforward. 1a, f of 1 means substitute 1. There we are, minus 6. F prime of x, pretty straightforward. Differentiate. The equation of the tangent where x equals 1. Well, we have x1, y1, and we need to find the gradient, which means x equals 1 into the derivative. So f prime of 1 equals 1, so now I have m as 1. So there we are. Y change sign y1 equals mx change sign x1. So y change sign y1, y plus 6. M is 1. X change sign x1, x minus 1. Yeah. And that simplifies y equals x minus 7. Number 2, see there's a point on the curve there. The gradient of the tangent to f at C is 7. Determine f prime x. Straightforward, differentiate. There we are, derivative. Determine the coordinates of C. Well, they've told you the derivative equals 7. Alright? So therefore I'm going to say, well, the derivative is 4x plus 3. I'm putting it equal to 7. Solving for x, I get x equal to 1. Now that I know x is 1, it says find the coordinates of C. I need to put 1 back in the original to find the y value. And we have our point. Number 3. The function defined by g of x equals x squared minus 8x plus 20. Determine the point on the curve where the gradient of the curve equals 4. The point on the curve of g where the derivative equals 4. Derivative 2x minus 8 equals 4. Solving for x, we get x equal to 6. Not finished yet because it says find the point. So we take that, substitute back to get the y value. 8. So there we have it. The point is 6, 8. 3b. Find the equation of the tangent at that point. Well, we have the gradient and we have the point. So straight into our formula. Y minus y1 equals m x minus x1. And we have our equation. Number 4, the functions g and f defined by those two equations, well, that's a cubic. Determine a, the gradient of the tangent to the curve of f at the point 1, 4. Well, that has nothing to do with that one now, hey. We have x1, y1. We need to find the gradient. They've been very kind giving 4. They didn't have to because you could substitute in and get 4. So f prime x equals 3x squared minus 18x plus 20. Differentiating that. Substitute 1 and we get 5. So we now have the gradient of the tangent is 5. B. One point on the curve where the tangent of the curve will be parallel to the line G. Well, it's where their gradients are equal or their derivatives are equal. So therefore, derivative equals derivative. Or derivative equals gradient to that straight line, which is minus 4. We solve for x. I divided through by 3 just to make it a bit simpler to factorize. There we are. So we get x equals 2 or 4. 4 is grayed out because it does say 1 point. Find 1 point. So we're finding 1 point, x equals 2. Substitute into the original to get the y value, and there is the point. Of course, you may have done the other one, so let's just put in what that one would be. Substitute 4 into the original, and we get 8, so there's the point 4, 8, just in case you found that one instead. Number 5, the gradient of that curve there equals 6 at the point where x equals minus 2. Well, the gradient of the curve means derivative of that equals 6 when x is minus 2. Derivative of that equals 6 when x equals minus 2. So, there we are. Derivative is 3ax squared minus x at x equals minus 2 at 6. So therefore I can substitute minus 2 in, and I can find the value of a. Number 6. That point lies on the tangent there. The gradient of the tangent is 2. Find the equation of the tangent. Well, this isn't calculus, this is straight algebra. Given the gradient, given the point on the line, there we are, y change sign y1 equals mx change sign x1. So y change sign 2, y minus 2 equals m. Gradient of the tangent is 2. X change sign x1, x change sign x1, 1.5. And y equals 2x plus 5. The value of p if negative 1, 2 is the point of contact. So, at the point of contact, the gradient of this line is equal to the gradient of that line. So, there we are, gradient, derivative equals derivative. Derivative, derivative, there. Or just the gradient is 2, it's a linear function. Solving for p, we get p equal to negative 2.